For, I want to talk about these down here, sine, cosine, tangent, and we want to look at this little picture right here, related to it. You should know that sine of an angle is opposite over hypotenuse, and cosine is adjacent, the close one, over the hypotenuse, and tangent of this angle is opposite over adjacent. That's from geometry. Now, since we know those particular things, I want to look at that in using the unit circle, and you'll see in a second. If I have this picture, all right, let's say theta is that angle right there. Just like if I said 2 pi over 3, wouldn't it be from here to this spot right here? 2 pi over 3 would be from here to here. All right, and if I want to create a right triangle in my unit circle, what I want you to notice, a connection between the coordinate here and the opposite hypotenuse and adjacents of a right triangle. So, actually I'm going to ignore this for a second. I'm just going to draw something on here. So watch. If I go and take this right triangle right here. Wonderful handwriting. All right? Does that triangle somewhat look like this one? If I went sine of an angle, sine of this angle right here, which is 30, all right, isn't it going to be opposite over hypotenuse? Now, if we look at this coordinate in the corner, doesn't that coordinate give me my two sides? All right? So if we look at that coordinate, isn't this your x and isn't this your y value? And if I went opposite over adjacent, well, also, wouldn't this be your y value and isn't this your x value? If you look at this coordinate, isn't that xy? So wouldn't that be your y and your x? Because the coordinate is really just a right triangle as well. It's kind of like a rise over run idea. Kind of see it? So, instead of saying opposite over hypotenuse, can I replace opposite and hypotenuse with x's and y's? And what is this length going to be if it's a unit circle? 1. The radius of this whole circle is 1. So won't this be 1? So can I kind of put a 1 there? This is now y, this is now x, and that's 1. So can I replace this with 1, this with y, and this with x? So what is opposite over hypotenuse in terms of x's and y's? Well, opposite of this angle right here is y. Hypotenuse is 1. So what can we write this as? Hopefully you can see, I'm going to write it as opposite is y over 1. Or can I just write it as y? So what we want to start realizing is when we see sine of an angle, it's really talking about the y value right here, or the y value in the corner. Because it's opposite over a hypotenuse, and it's talking about the y value of the right triangle created by that terminal side. Look at cosine. Isn't it adjacent over hypotenuse? So isn't adjacent your x over 1? So instead of seeing it as adjacent over hypotenuse, can I see it as x over 1, which is x? So you're going to start realizing, oh, whenever I see cosine of an angle or cosine of 30 degrees, what that means is, oh, it's saying the x value of the right triangle, or the coordinate right there, the x of the coordinate. It's going to take some time getting used to. It's kind of weird. So we're going to start kind of ignoring opposite over hypotenuse and adjacent over hypotenuse and thinking of it as x and y. Because our hypotenuse is 1. So why really pay attention to it? You can kind of ignore the hypotenuse of 1. It divides out really nicely. Tangent's a little trickier. Tangent is opposite over adjacent, so opposite over adjacent. Well, isn't that just going to be what over what?
Y, x over y.
Y over x. So can I replace this with simply y over x? And this is where we're going to start going to. Thinking of them as y over x or y or x. Okay, so whenever I see sine of an angle, I'm thinking about the y value of that terminal side, this angle. Now what's weird about this picture is my angle is all the way over here, correct? So aren't we now looking at this little corner? That's really your angle. So whenever I do this problem, I'm not going to use this angle. I'm going to use the little angle inside the right triangle to do these problems. To do this down here, I'm going to use that little angle right there. So if you look at that angle right there, it's always going to be, sine is always going to be your y value, and cosine is going to be your x value, according to what we said down here. And we're going to use all that to answer these questions. That is where we're going. If I want to find sine 120, what I want to do is first find the terminal side of 120. So hopefully you can see 120 is right here. And then I make a right triangle. Now, from that right triangle, sine, well, we said sine here is the y value of that right triangle. So what is that y height of that right triangle? Well, could you look right there? Or could you know that's a 30, 60, 90 and know the longer side is square root 3 over 2. The shorter side is 1/2. So can you tell that the y value, the opposite over hypotenuse, is square root 3 over 2? So your answer is simply square root 3 over 2. All right, let's do this one. Cosine negative 135. So first we got to find negative 135. So hopefully you can see negative goes backwards. So negative 135 is 90 plus another 45. So hopefully you can see that we're talking about that line right there. And can I create a right triangle? Now, when I look at that right triangle, again, negative 135 created that line. When I look at this right triangle, I want cosine. Cosine tells us we're looking for the x value of that right triangle, the adjacent over hypotenuse. So that is my x. Well, isn't that a 45, 45, 90 triangle? So aren't both sides square root 2 over 2? Can you see it right down here? And I want the x value. See how the x value is negative square root 2 over 2 because it's in the negative direction. It's a coordinate. So I want the x value of that. So my answer for this is negative square root 2 over 2. Tangent is y over x. So tangent 150, first thing we got to do is find 150. Do you see it right here? And we make the right triangle. So let's make a right triangle. Can you tell that's a 30, 60, 90? And if I'm doing tangent, isn't tangent one opposite over adjacent? Or the y value over the x value? Well, can you look at the coordinate? Aren't we going to want the y value over the x value? So watch what happens. We're going to do the y value, which is 1/2, divided by, which means over, negative square root 3 over 2. Now the reason I wrote it like that is it might get ugly if you write it as over. And let's do the math real quick. When we simplify this, if you do the math here, when you divide, don't you flip and multiply? Are you okay with that? When you divide, you flip and multiply. Do you see the 2's dividing out? See these 2's dividing out? Now do you have that? It doesn't matter if the negative is on top, bottom, or middle. So that becomes the value of tangent, because you actually have to take the y divided by the x. Tangents are uglier. Now, do you remember also something from geometry that we don't like square roots in the denominator?
No, I don't.
You might not remember that, but if you want to get rid of square roots in the denominator, you have to multiply top and bottom by the denominator. So I'm going to use this space right here. You're going to take negative 1 square root 3, and I'm going to multiply it by square root of 3 square root of 3. And when you do that, you get negative I can't write on there. You get negative square root 3 over, what's the square root of 3 times the square root of 3? Square root of 9, which is 3. So your answer, kind of ugly, let me rewrite that. Your answer for this particular one is negative square root 3 over 3. That would be the answer to this problem. It's a lot. This is the ugly one. This is about the ugliest one you're going to run into is tangents when you have to divide a special right 30, 60, 90 triangle. Some of them are easier to reduce, some are harder. This is the hardest answer to finalize. Most of them, see how easy these were? Just look and see them. All right, tangent negative 90. Well, negative 90, doesn't that mean you go down to right here? Now, is there a triangle right there? No, but do I have a coordinate? So if I look at this coordinate, tangent says y over x. Well, can you take the two coordinates? Can you take, the two values of the coordinate, and can you do y over x? This is actually pretty easy. There's y, there's x. So y is negative 1 over 0. Oh, wait. Can you divide by 0? You must have something in a fraction. Bottom always has to have a number. You can't have a 0, nothingness. So this is called undefined. Undefined. If you ever divide by 0, it's undefined. Which you'll see something later when we get into graphing tangents why that means. But for now, that is actually undefined. Now this one, do you see how I've switched from degrees to radians? Yeah. Well, can you just simply go find 4 pi over 3? Where's 4 pi over 3? 4 pi over 3. There. Nope, nope, nope. Where is it? Is it right there? Yeah. So I want that spot right there. So let's draw that one in. 4 pi over 3. Okay. And for sine of that, sine is my y value. Well, isn't your y value that longer side? And have you caught on yet that the longer sides are square root 3 over 2? Mm-hmm. Can you also look down here? There it is. Oh, why is it negative? Oh, because it's down square root 3 over 2. Do you see how it's down in the coordinate-wise? So you got to watch those negatives. Some people miss those a lot. Like, oh, negative, darn it. They get the number, they forget to put the negative square root 3 over 2. Negative. So watch out for those negatives and just look for the y value. You know, if that was cosine, what would be your answer? If that was cosine of this, wouldn't it be negative 1/2, the x value? Now, if I want cosine 7 pi over 4, we first have to find 7 pi over 4, and it's right there. So I'm going to draw my right triangle. So here we go. Let's draw a 7 pi over 4 right triangle. And do you notice it's a 45, 45, 90? So that both these sides are the same. So I know it's going to be a square root 2 over 2. And for cosine, I want the x value. So I want this right here. I want the adjacent to that angle. And that would be positive, because we're going positive x direction. So my answer would be the square root 2 over 2. That is an ugly 2. Square root 2 over 2, positive. Now, if we were asking for the sine, what would that be? If it was sine, you want the y value, so it would be the negative square root 2 over 2. You could always convert. If it went tangent, would you just divide the 2? Yeah. Last one here, pi over 4. Let's find pi over 4. It's right there. So let's draw that right triangle. All right. And I want tangent, which is y over x. So y over x. Well, if this is a isosceles triangle, aren't those the same? Yeah, look right here. And what's anything over itself? 1. So are we okay with just putting 1? Now, if you want work for it, what you should notice is it's this. It's that divided by that. And do you understand that will give you 1? Because when you take the y divided by the x, you get 1. All right, in summary, how do we do this kind of problems? You look at the angle, It could be a radian or a degree, and you draw your triangle. Then once you have your triangle, if it says cosine, you want the x. If it says sine, you want the y. If it says tangent, you want the y divided by the x and reduced. The key is finding that terminal side, creating the triangle, knowing which one's which, and your answer comes up pretty quick. These aren't the longest problems. There are a lot longer problems in them. But can you solve these without a unit circle? You must first learn this unit circle. If you don't know this, this whole type of question is completely confusing.